Hello, welcome to the first video of our machine learning course at the University of Hamburg. In this presentation, I will give an introduction to the field of machine learning, and I will comment about the content of this course. So let's start. In this presentation, I will cover 5 specific points. First, I will tell you about machine learning and the main 3 different kinds of machine learning problems that we study. Then I will say something about our course, specifically what are the topics that we will cover. And then I will give a more technical introduction to the 3 different kinds of machine learning, which are supervised learning, unsupervised learning, and reinforcement learning. So what is machine learning? Machine learning refers to algorithms used to extract patterns from data and learn a mathematical model that could be used by a computer program to make intelligent decisions. So what does this definition is telling us? So first, we need some data, exemplified here like zeros and ones, and this data could represent anything that can be stored in a computer. So it could represent images, video, or simply data from a website, for example. Given this data, we need to extract patterns or learn patterns from this data, and these patterns will be stored or captured by a mathematical function that here I am calling it y equals f of x, where x will be some input information and y is going to be the output of our model or mathematical function. Training machine learning algorithms consists in estimating the parameters of these functions, and depending on the kind of data that we have available and the algorithm that we used is the kind of machine learning problem that we are solving. So once we have estimated this function f, then we go and we program some software like this example here, and our software is going to serve to make decisions. Like for example, if y equals a, then do action A. Else, if y equals b, then do action b, and so on. Let's take a look at the first example. This is a case of supervised learning, and this is a specific case of a problem called regression. Consider that we are given the characteristics and prices of several houses from a specific city, and we need to develop a software, a program, for predicting the price of new houses. So for example, here we have a house which living area is around 560 square meters. It has 2 bedrooms and its price is 37,000 euros, for example. And suppose that we are given many examples of these houses. In this specific problem, we need to learn a mathematical model that, given some living area and some bedroom, our program will predict what is the price of that house. So this is a very common problem in machine learning. It is a kind of supervised learning, and specifically it is a regression problem. What makes this problem a supervised learning problem is that we are given some inputs and outputs as examples. Like here we are given the living area and bedrooms, and we are given also the price of the house. So we have pairs of inputs and outputs. That's why this is called supervised learning. There is another kind of supervised learning very similar to this one, which is called classification. In this example too, we are given a set of digital images of blood samples containing Chagas parasites. The Chagas parasites are these artifacts here, and the problem consists in deciding if a digital image contains at least one of these parasites. So again, we are given examples of how a parasite looks like, and we can take examples from here, for example, saying, okay, this is not a parasite. So again, we are given pairs of inputs and outputs, and we can learn a model that will answer us if an input corresponds to a parasite or not. There is a second kind of learning problem, which is called unsupervised learning. One very specific case of unsupervised learning is called clustering. In clustering, we need to create or detect groups of information. Like, for example, given a set of text phrases written in two different languages, decide if a new text phrase belongs to one of the languages existing in your set of phrases. So, for example, we have here sentences in Spanish and sentences in English, but we are not given information about the labels of these phrases. So we are just given the phrases, but we are not told, for example, this phrase is in Spanish and this phrase is in English. We are just given the inputs. So the idea behind this problem is that we need to learn patterns that make a phrase look like Spanish, and also learn the pattern that makes a phrase look more like an English phrase. But we are not given these labels. This is why this kind of problem is called unsupervised learning. We are given only the inputs, not the outputs. There is a third major machine learning problem, which is called reinforcement learning, and this is mainly used for designing control systems. Like in this example, given a history of the commands used to control a drone, decide which is the best command to perform in order to avoid a collision with the ground. So suppose that there is a person which is an expert controlling this drone, and we can store information about the different states of the drone and the different actions that this human expert is performing to control the drone. So he is avoiding to let the drone fall down. This kind of learning is very different to the two first ones. This is a bit more complicated in the way it is defined, and we have seen that in general we can talk about three major kinds of machine learning problems based on the data available and in the decisions that we need to do. We can talk about these three kinds of machine learning algorithms. So in the case of supervised learning, we are given inputs and outputs, many pairs of these inputs and outputs. In unsupervised learning, we are given only the inputs. And in the final case of reinforcement learning, we talk about the states of the system or the environment. We talk about actions that we need to perform in this environment. And we talk about a concept called rewards, where the rewards are simply signals saying the system if it is performing good or not. So currently there are many sciences that are getting involved in machine learning, and we are seeing developments coming from many of these sciences, mainly of course from computer science, also from artificial intelligence. And we can say that this field, machine learning field, was born actually from the artificial intelligence community when they started thinking about algorithms that can emulate the human intelligence. Also, we are seeing a lot of work coming from the bioinformatics field, where people is trying to learn patterns, for example from the genome strings, the human genome, for example. Also for neuroscience, where people are trying to define theories about how our brain works, And once they have these theories, they developed mathematical models that try to emulate these theories and try to explain how the brain works. In the same way, in psychology, people is studying how we are making our decisions, and these theories are also emulated using machine learning models that can be tested using computers. And finally, one of the other major fields that are developing a lot of machine learning algorithms is robotics, where we are trying to extend the field called cognitive robotics. So now let's talk about some practical aspects about machine learning. Using machine learning algorithms usually involves at least two phases, which I call the learning phase and the application phase. In the learning phase, we get the data. We choose an algorithm, a machine learning algorithm, whether it is supervised, unsupervised, or by reinforcement. We train our model and we test it with our available data. Once we are confident enough that our model is working well, we take our model and we deploy it in the final system, which usually it is a more complex system than our machine learning system. So we take our model, we code a program, like for example in Python, and then we deploy it to start making decisions in real life. Usually, when we do this for the first time, our model does not perform as good as in our learning phase or testing phase. So this is very common. At this point, we need to discover where we made a mistake, possibly because we ignored some variables that are very important for the final decision-making process. And usually we will need to go back to the first phase, where we need to refine our model, train it, test it, and go back again to deploy it. So we can spend some time going forward and backward between these two phases, learning and application phase. So what is the best way to learn machine learning? Here is a recipe for an optimal learning of machine learning. First, you need to be able to understand and classify your problem in any of these three kinds of machine learning problems that we have talked about: supervised, unsupervised, or by reinforcement. Once you have decided which of these is your problem, then you need to go and understand the mathematics behind the algorithms that you are going to use. These mathematics include like basic statistics, probability, calculus, or linear algebra in most of the cases. Once you have understood the mathematics, you go on and you get into the algorithms. In this case, I'm talking about complexity theory in algorithms, data structures such as trees or graphs. So this is very important because usually these algorithms are going to be run with too many points, too many examples, something that we call nowadays big data. So you want your mathematics to be optimally implemented, and you need to know these data structures and the complexity of the algorithms that you are programming. After that, you go on and you will implement your algorithm using, for example, Python. And once you have implemented it, you will need to run experiments, run programs, and plot graphs so you can see if your algorithm is doing what you expect it to do.